Okay, guys, and welcome. And today I'm going to talk about scientific notation and significant figures. This will be pretty short. This is really just combining a few things that I've already talked about, just kind of making sure that you know some, and combining some algebra that you may have known or may have forgotten. So just kind of solidifying this idea of how to use scientific notation to properly show the number of significant figures. So we talked about how to write scientific notation, and I already mentioned that scientific notation is really great for showing significant figures, because when you have a number like 2.10, you know that however many numbers are in the coefficient part of the number, that is the number of significant figures. So there are 3 significant figures here. So we never count the numbers as part in the exponent. It's only in this red portion here in the coefficient. So the way that scientific notation is written, remember, numbers in proper scientific notation have some number, some non-zero number like 8, and then something after it. So the decimal point is always right after the first non-zero number. So this is proper scientific notation. This is not proper scientific notation. And this is not, and so that's not proper scientific notation, nor is this. That's not proper scientific notation either. Just because it has an exponent attached doesn't make it proper scientific notation. Well, a little bit more we need to talk about is there's some algebra that might help us with multiplication and with scientific notation and how to write the right number of significant figures. So honestly, coming up with the correct number of significant figures when you're multiplying numbers in scientific notation is super easy. So one thing to help remember, we don't have to convert or anything. It's really easy to do. So remember from algebra, if you have, so we have a times 10 to the x, and then multiply that times b times 10 to the y. Remember, we can rearrange multiplication any way we want. I'm going to rewrite these as dots so they don't look like actual x's. So I'm going to rearrange this to be a times b times 10 to the x times 10 to the y. Now, do you guys remember what 10 to the x times 10 to the y is? Very good. So this whole thing becomes a times b times 10 to the x plus y. So this a times b, these are our coefficients, and so however many significant figures, whichever has the fewest number of significant figures, that's how many significant figures you write. So it becomes really easy to do this. This is also something really beneficial about this. Now, really, you're not going to really need to do this very much, because your calculator will understand scientific notation just fine. Your calculator will do the math just fine. Sometimes you can screw up with a calculator. And so what can help with that is recognizing this bit. So if you see something that's like, like, I'm going to make the math easy on myself. 1 times 10 to the 5th times 1 times 10 to the negative 3rd. If you punch it in your calculator and you get this, you know there's a problem, right? Because 10 to the 5th times 10 to the negative 3rd should be 10 to the 5th plus negative 3, which is actually, this should be 2. So sometimes by the nature of the coefficients, you might have your exponent might be one larger or one smaller than you would expect. But this gives you a general ballpark. So if you're expecting something times 10 to the 2 and it ends up being times 10 to the 3, that's probably not a problem. Or if it's 10 to the 1, that's probably not a problem. But if you get 10 times 10 to the 10th, that's an issue. Or 10 times 10 to the negative 5th, that's probably a problem. Division works the same way. So multiply them, add the exponent. Division works the same way. You just divide the exponents and divide the coefficients and subtract the exponents. We'll do some practice on this in just a little bit. Okay. So I can do without trouble, and this is what I said. So if you're doing this, dividing, right? You're looking at this, 7.04 times 10 to the 2 divided by 2.2 times 10 to the negative fourth. Remember, what you're going to get is you're going to get 7.04 divided by 2.2. So you're going to expect something around like, 3.5 or a little less than. Divided by 10 to the 2. This 10 to the 2 divided by 10 to the negative 4 becomes 10 to the 2 minus 10 to the 2 minus negative 4, which is the same as adding 4, right? If you subtract a negative number, it's adding it. So you should expect something in the sense of 10 to the 6th. If you got 10 to the 5th, 10 to the 4th, that wouldn't, 10 to the, not 10 to the 5th, or 10 to the 6th, or 10 to the 7th, that probably wouldn't be that big a deal. But if you got 0.032, you know you did something wrong. So this is a thing that happens sometimes. People will get this on their calculator. This can often be because you don't know how to input numbers in scientific notation in your calculator. I am going to make a video next on how to use your calculator, so this should help. So, if you're just doing multiplication and division, this is really easy because you just slam all the numbers into your calculator and then just give the right number of significant figures at the end. Very easy. Okay, addition and subtraction is way more wonky. It makes things much more difficult. So here's the basic idea. If you have a times 10 to the x plus b times 10 to the x, notice they're both x. The exponents have to be the same thing, right? Then you can add the coefficients, but the exponents stay the same. So this is the idea of if you had 3 times x, I'm just calling this x, plus, right, 4 times x, what we can do is remember you can pull this out and you can say, oh, this is 3 plus 4 times x, which is 7x, right? So that's what we're going to do here. So I want you to take note that this is actually what you're really doing when you have two numbers in decimal notation. If you take 2 plus 4, 2 plus 4, right, we can really think of this as 2 times 10 to the 0 plus 4 times 10 to the 0, and what we then get is 6 times 10 to the 0. Now, this works also if this was times 10 to the, if this was times 10 to the 4, and times 10 to the 4, this would also work, right? So you can just add them together. Okay, and subtract them. So why is this relevant to significant figures? Well, the problem is when you look at two numbers in scientific notation, if you try to add them together, if you try to add 3.2 times 10 to the 5th plus 1.1 times 10 to the 4th, you may be tempted to say, oh, it's addition, easy. Okay, well, I'll just punch it in on my calculator. And actually, that's actually not what I want to do. I want to give a better example. 3.32. There we go. That's better. You may be tempted to punch this in on your calculator and go 3.32 times 10 to the 5th plus 1.1 times 10 to the 4th. And your calculator spits out 3.43 times 10 to the 5th. And then you would say, you might be tempted to say, oh, well, this has the fewest decimal places, so that's the tenths place, so we just round to here. That is actually incorrect. The reason that's incorrect, and this may seem like I'm flying in the face of everything I've told you, I'm not. You have to understand that this 3 is not really in the tenths place. If we were to put this in decimal notation, right, 3, and then we move the decimal place 5 times, right, this 3 is actually in the 10,000ths place. And if we put this out in scientific notation, right, this 1 here is in the thousands place, right? So this 3, this 1 isn't. So when we add them together, we actually get 3, 4, 3 1,000, right? That's what we're actually getting. This means that we should really round up the 3 here. How do we do this without having to pull everything out to decimal notation? Well, I'll show you. We do this by just moving the decimal point enough on one of these so that they're in the same power of 10. It doesn't matter which one I move. I'm going to move the 5. I'm going to move this one. I will move, which way do I need to move this decimal point, left or right, to make this 10 to the 4th? So remember, I'm wanting the exponent to go down by 1. I'm effectively going to divide it by 10. So in order to do that, I need to multiply this part by 10, and I do that by moving the decimal point to the right. Remember, every time you move the decimal point to the right, the exponent goes up 1. So, wait. Sorry, it goes down 1. I had that backwards. Every time you move the decimal point to the right, it goes down 1. So, 3.2 times 10 to the 4th. I want you to understand these things are equal. These are equal. Plus 1.1 times 10 to the 4th. So what we get now is when these exponents are matched, you can just round with addition like you normally would. 34.3 times 10 to the 4th. Now we need to put it back in proper scientific notation. I just move the decimal point back one spot. 3.43 times 10 to the 4th. Everything is good. Okay. And that's really all I have to say about numbers in scientific notation. So let's do some practice. These are all just examples of the same, and the lecture notes are online. Okay, so I want you guys to try these. I'm just going to put all of the calculator answers up for the first. I'm just going to slam the calculator answers up for all of these, and then we'll talk about them all. Okay, so here are all the answers that I got out of my calculator. Now, again, I might have done something wrong when I calculated them, but here's what I got. So for this first one, so the first 4 are all nice and easy. This is all multiplication and division, so all we have to do is look at the number of significant figures. So we look here. This number has 4 significant figures. This number has 3. So our answer should have 3. So I'm going to erase this and make it 3 significant figures. Easy. This one has 2. This one has 3. Our answer should have just 2. Now we have to round up because we're going to remove this last one. So I'm going to make this 6.9 times 10 to the 5th. Here, same rule, because it's division, it works the same way. So here I've got 1, 2, 3, 4, 5, 6, and here I've only got 3. So we round to 3 significant figures. Easy. I'll write that as times 10. Oops. That was a mistake. Times 10 to the 1. And then here I've got 1, 2, 3, 4, 5, and I got 1, 2, 3. Again, we're going to round to 3 significant figures, but we have to round up to 6.24 times 10 to the 3rd, which is nice. And then, now here, we have to, so multiplication, division, easy. Addition, subtraction, you need to stop and take a lot more thought. So let's pay attention to what's going on. We need to get these both to where they have the same exponent. I find it's generally easier to go to the higher exponent. So I'm going to leave this as times 10 to the 6 plus, keeps happening to me there, plus, now which way do I need to move the decimal point to get this to go up to 1? I need to move it 1 to the left. So 0.309 times 10 to the 5th. Now what's important is this is what my calculator spit out, so I already have that information. So I know that this is the answer, but what I need to know is where to round it. So when I have these now both, and that should be 6th, I screwed that up there, so that's 10 to the 6th, and so there, I now go out to 1, 2, 3 decimal places, 1, 2, 3, we go out 1, 2, 3. It's fine as it's written. This is fine as it is. Here we need to do the same thing. I'm going to leave this as 8.313 times 10 to the 7th minus, now we've got to move this. I need to move this left 3 times. 10 to the 7th. This becomes a 7 now. So now we look, we go 1, 2, 3, this goes 1, 2, 3, 4. You may have initially thought that we should round to only 1 decimal place because of this. But this 4, this is a much smaller place. The uncertainty is actually a lot less in this number. So here's where you need to go to. So hopefully that makes sense. Okay?